So one thing you can do is you can so you can graph these pretty easily, right? Because I know that if I take the square root on both sides, I make a boo-boo, right? All of a sudden that's complex in nature, right? So, and even if you did it, yeah, you just wouldn't want to do it that way. So maybe instead we factor this. But before we proceed any further, I know the key point is at -2. Sorry for missing that one earlier. So that means that we have this absolute value function, -2, sorry. And it's supposed to be hitting that at the vertex there. And then you have that, of course, crossing at its 0, which is going to be +2. And then you have the translated quadratic, which is going to look something like this, right? So you can see that they do have a solution here for that, and it has a solution here for the other one. You see, even just a rough sketch of the graph without even doing that many numbers tells you that if we look at the left side, it's probably not going to have a solution, right? Well, let's investigate. First off, we took the square root. We're like, no, we couldn't do that because it's complex, right? So that eliminates one situation. Let's see, minus 3x plus 6. I think that's right, right? But look at that. That don't look right, right? That looks like a nightmare. So if I try to solve this, if I test the discriminant here, or the delta, I've got what, b squared again, that's -3 squared minus 4 times 1 times 6. So yes, you've got 9 minus 24, -24, which gives you the square root of, help me out here, 24 minus 10 is 14, -15. Thanks, I'm tired. So that's going to give you root 15i, no solution. So that means that we reject this branch condition. So we're going to say there's no solution for this side.
Yeah.
So then now that we got the delta out of the way, we don't even have to do that huge polynomial, right? We eliminated a lot of work, didn't we?
Yeah.
So now what I suggest you do is, if you're understanding this, go ahead and try to do the right side yourself. Now, if you can graph them by hand, you don't have a calculator, perfectly acceptable on a test. I highly recommend graphing by hand if you can. If you can't, don't. You're just wasting your time. Some functions aren't always that convenient to graph by hand, or maybe you forgot, but you can just do what you can. But here, go ahead and do the math. I'm ready. Show me what you got.
Okay.
Very good. Anytime you square root, remember, if we do that, then we need to do a plus or minus over here, don't we?
Right.
Now, we don't have to do it on both sides because you will have equivalency. Maybe the plus is the minus over there and the minus plus is over here, those, no big deal. So we just keep one plus or minus. And so now you've got x minus 2 wait a minute, did I do this right? Hold up. No, I'm sorry. Wait a minute. X plus 2 square rooted. No, we can't. No, we can't do that. I'm tripping. We went backwards. My bad.
Yeah, it's x minus 2.
Look at that. Well, even if no, it's x. That is on the right side, but we don't want to do that. We actually want to expand this out, actually, because we can't solve a square root like that, or you don't want to. Trust me. So we're not going to do conjugate method here. So I'll teach you that later. But what you want to do is you want to factor this again. I'll let you take it from here, okay?
Okay.
You just drop the x plus 2, of course. I'm going to bring this up for you. So then what we discovered, okay, you did a good job here. Now these you can leave your solutions, but since it's two of them, I always put x1 comma 2, right? And so you know what you're, especially with things like this, you're not always going to get the best solutions when you solve this, right? And that's why we always use the delta or the discriminant first, right? Because we want to get that out of the way. It might save us time if we don't want to waste time using synthetic division or anything like that. Um, so now that we know that this solution is perfectly acceptable, those are the two roots right there. You could get their numerical solution, so I'll go ahead and I'll just kind of provide that, and we'll call it a day on that video. But let me grab. Hold on, let me see. There's a few more that I'll have you do in your practice sets, though, respectfully. But I think things are going well. I think we picked our pace back up, don't you, Padawan?
I would say so, but we cannot miss a single day, man.
I know we're doing good. All right. Dang. Zayd B1 Kenobi, Jesus. All right, let's. No, you're good. No, you're good. No, I'm proud of you. That's good. So I don't know why I did that earlier. I'm losing my probably because I'm just getting mentally drained. Let's go over here. I know you are. I'm not playing. So let's go ahead and do this. Let's do solve. We get to learn. People get to learn the solve feature on Mathematica when they watch my videos. Isn't that wonderful? So x squared. Let me go back. Where were you? Over here. So we had, where are the answers? Let's see, right here. Minus 5x plus 2. Equal 0. You have to do double and then close your bracket. Done and done. Hey, wait. Yeah, that should be it. I want to make sure that this is legit, though. So in order to see if it is legit, just do that. Okay. Those are the two roots numerically. So your calculator can get the root 17 by hand and all that. So what I'm going to want you to do when you do the homework, right? One of the biggest things that I'm going to have you do when you do the homework is I'm going to have you actually use your calculator to get the approximation for root 17, okay? Now mine spits them out at the same time. But if you can get this by hand, right? Instead of right, yeah. But also, I want to also there's three ways to do the to represent the answer. For one, you can do it by hand over here and leave it, and this is acceptable. This is a solution. But if they want the approximation of root 17, you would have to get that in your calculator as decimal. And these are not root 17 by itself, my calculator. This is the entire value. So then you give me the entire value of x1 equals what, and x2 equals what. So that's exactly what we're going to do here to show and finish this off. So what we have for both of them is this, and that's going to be minus whatever that is over 2, and that approximated over 2. And those are the two solutions. Another way you can do this is to use your TI-84, right, and use the intersection feature that they have on that. So, or you can use Mathematica.
So on my TI-84, if I were to take the approximate root of square root of 17.
Hold on.
Right.
84.
It gives me 4.123105626 for the square root of 17.
Did you already oh, okay, yeah. Intersection feature screenshot command. So you go to y equal, hit graph, and then hit second trace, and then the calculate menu.
So for the y, you want to show this, right? Square root of 17 divided by 2.
Well, what does your calculator give you for root 17?
Hang on.
Tell me again.
I got 4.123105626.
4.123 over 2. 4.123 over 2. So then now you keep simplifying so you don't make a mistake, right? Now write down what you get for that fraction there. In other words, what's this fraction and what's this fraction, right? Because I want it all the
Let me
way.
do 4.123 divided by 2. That is 2.0615.
You got, what was 4.123 divided by 2 again?
2.0615.
So we'll call it 2.062. No big deal, right?
Yes.
So then now you've got these two solutions. X1 is equal to negative 0.5 because that's what negative 1/2 is, minus 2.062, and you have x2 is equal to negative 0.5 plus 2.062. And now you do the last bit and get the approximation. The approximate solution. And those will be
So
the
that's
two
negative
numbers.
negative 0.5 minus 2.62. That is negative 2.562.
Huh. Let me. Whoa. Yeah, that root 17 is correct. And that would be correct. Huh. Oh, this was supposed to be a -5 all along.
That's
Or
what I'm
pos.
saying.
I am so sorry. I stopped you, and I should not have done that. Positive. Yeah. So that's 2.5 minus in that. Okay, so let's correct that real quick.
So that is the whole process we did was wrong.
No, it's just the b over 2a part.
Yeah, I know.
Oh, you're being smart. Okay, all right, you got me. So 5 over 2, so that's going to be 2.5. Now we do it, and this is definitely going to be this 0.438 approximately. That's what that one is.
That means the answers in the box is like -4.
Yeah.
So that means if it's 5 over 2, then this also has to be 5.
Oh yeah. Thanks for that correction. Yeah, we need to put that. These are both but they're positive because 5b was negative, so it makes it positive. We can't forget because negative b over 2a. So it was negative 5 being a positive 5 over 2. And yeah, that's it. That's how you would do it. Good job. You're capable of that. But the acceptable solution, you can always leave it in exact form. This is exact form, and that's fine, but you will not be able to kind of like humanly see it unless you go through this process. Or you could use the TID4, right? And I can put that on the next slide on how to do that. And I just taken it from Google here on AI overview, and it's like, dude, just use dummies, you dummies. So let's go over here, and I'm going to show you how to do it. That's how you do it on your TID4. Once you put your graph in, right? So and again, this isn't you would have to use the graph, not the x squared minus 5x plus 2, but you would have to graph the line x plus 2 and x minus 2. So the right branch, right? So the right branch had the solutions here. The left branch did not. So if you graph these two, you can get the intersections, right? That's what we're trying to, and you can get that in your calculator. And that's a good way of testing your work and working through a problem. Really, truly understanding a problem is the usage of that technology, right?
I'll actually try doing it real quick.
Yeah, go ahead.
So it was
Anakin Chancellor Palpatine is